thanks everyone for coming. My name is Jim, and let's jump in. So the 4 things I'll be talking about today, of course, Terraform. If you're at HashiCorp, I assume you know about Terraform. AWS, specifically the AWS Terraform provider. Localstack. If you haven't heard of Localstack before, it's a tool that will create a local testing environment with the same functionality and APIs as the real AWS cloud environment. There are free and paid versions of Localstack. The paid version, has more functionality, but this talk I'll focus on the free functionality. And Drone, which is a container-native open-source continuous integration tool, started in 2012, so it's been around 10 years now. It has over 25,000 stars on GitHub. And Harness, the company I work for, acquired Drone in 2020. So I'll be sharing how to use Drone to test AWS resources against Localstack under continuous integration. So the goals of this talk are that even if you don't use AWS, I hope that this talk will get you interested in writing integration tests for your Terraform modules. I hope you see how Localstack can save time and cost versus bringing up real AWS infrastructure. And I hope that this will encourage you to run those tests under continuous integration. And of course, I love Drone, but Localstack does work with any CI tool that'll let you run Docker containers. So I just talked about the different tools I'll be using to run the tests, but not how to write the tests. So I'll be showing 2 different methods. The first is Terraform itself. So show of hands, did anyone know that there's a test command built into Terraform? Awesome, some people. I actually didn't before I was putting this together, so I learned a bit. But there's been a test command built into Terraform since version 0.15. So it's a way of writing tests directly in HCL. Unfortunately, it's still considered experimental, so it could be unstable, and the syntax could potentially change. And then the other is Teratest. So Teratest has been around for a while. It's developed by Gruntwork. Tests are written in Go. And so here's links to both of these tools if you want to find out more. So for this talk, I put together this example repository. It's an AWS networking module where it creates all the things you would expect to see in an AWS module, VPC, public and private subnets, NAT gateway, all that kind of stuff. So if we start to focus on what each of these files mean, if you've looked at Terraform modules before, hopefully these files are familiar to you. Main, outputs, variables, and versions. So main defines all the resources. Outputs defines information you want to get back out of your created infrastructure as variables or outputs. And then variables, which is anything you take as input. And versions defines the versions that your module is compatible with. Then the Terraform CLI, when I was talking about running Terraform Test, that looks for files beneath the tests directory, and I believe you can have any directory name beneath that. My directory is named example. And so if we look at that file, I have my editor open somewhere. Here it is. This is big enough. So here's that test file. So there's a built-in provider called built-in test that you define. And then, of course, you define your module. This is in the same directory, so it's up relative path up 2 levels. And then all the inputs that are required for this module, CIDR ranges and that sort of thing, a tag name of demo. And then now you'll see, now we're actually going to run those the tests to see if what gets created is what we expected. So we're going to do a data lookup for the NAT gateway ID. And then we can run assertions. So this is a resource that's built into this custom or built-in provider for tests. in the resource is called test assertions. So we can do checks and equal checks. So I have two here. One is just checking that the VPC ID that comes back starts with VPC dash. Every VPC should start with that in AWS, so that should never fail. And the other thing I'm checking for is if the name tag on that NAT gateway Elastic IP, if it comes back with demo, which is the same as the tag name passed up here. So that's it for that piece. So Teratest looks at Go files that are in the test directory. So if we look at that one, this is written in Go, of course. So this is what it looks like. These variables are all the same as what you just saw in the other test. Same values. And the same tests are running, looking for that VPC ID starting with VPC dash, and that the output over here for the tag comes back as demo. So you might notice this is a little different than the previous example. So this example was doing a live lookup, a data lookup on real running infrastructure, versus this is looking at an output. If anyone from Gruntwork is here, I'd love to know if there's an open pull request on this to make it so you can override the endpoints that Teratest looks to when running tests. And we'll see why that's important in just a second. So, oops, we jumped ahead. So the next is this file that is going to override values that are required by Localstack. So this file right here, if you've ever worked with AWS, this provider block looks probably a little similar, but there's a lot of variables here you would never set because it disables a bunch of security features and that sort of thing that you wouldn't want to do for real. But in tests, it can make sense. So this is turning off some checks, and then it's overriding endpoints that Localstack's going to provide. So instead of talking to the AWS APIs, it'll talk to Localstack instead. So I probably only need the EC2 override here. I just left all of these in because it's what they give you in their documentation. So it just gives you an idea of all the different endpoints that you can override when you use Localstack. So, so this works great for the Terraform tests because when they run, they look at what the provider is telling it to talk to. Teratest, as far as I know, like I was saying, you can't tell it, don't talk to the AWS API, talk to this other API. I'd love to know if that is planned to change in the future, but at the moment, I think that's just how it is. And then the last piece is this drone YAML file in the root. Oops, back over here. So if you've never seen a drone YAML pipeline configuration, it looks very similar to Docker Compose. So I've defined two pipeline stages here so I can show both of these tests running independently, side by side. So to run a service for the duration of a pipeline in drone, you just define it as a service like this. So I'm doing that for Localstack. And then I have a couple of steps that run my tests. So the first step just makes sure that Localstack's up and healthy before the next step can run and run tests. So here's the test here running. This is Teratest. So it's explicitly calling a specific test. And then here, the second pipeline stage is almost identical, except that it's going to run Terraform Test. So if we have a look at our run, this takes a couple minutes to run, so I'll just show you a previous run. This is the drone web interface. So here I committed a change to that tag on that NAT gateway IP that we wanted to be demo. And I changed it by adding a prefix, so it would fail that test. So here, if we look at each of these steps here, you can see Localstack coming up, running as a service while the pipeline runs. And then here's the running test running. So this is Teratest. So this is the output that you get from Teratest. It's very verbose. It shows you all the modules being downloaded, all of the plan output or apply output, because this is actually running Terraform apply. It's creating infrastructure. Even though it's only talking to Localstack, it's, as far as it knows, it's creating real AWS infrastructure. So a little bit of the way down here, we'll see the test fail any minute now. It's just a lot of output. it's coming. There it is. So here's the test failure where we expected demo to come back, and it had a prefix instead. So once that fails, then it runs Terraform destroy. And you see all of that output in a Teratest run. And finally, the output at the end. So the same stuff is happening behind the scenes when Terraform Test is running, just you don't get any of that output. I don't know if this is a planned improvement in the future. It would be nice to be able to see that output, but all that apply, test, and then destruction happening, you don't see when you run Terraform Test. But you get a very clear result telling you what failed. So that's an actual run and what it looks like. So does anyone want to guess what happens when you run these same tests and you actually bring up real AWS infrastructure? Does anyone think it runs faster when you bring AWS infrastructure? No? You're right. It takes much longer. So I ran that test 7 times along with bringing up real AWS infrastructure in their own separate pipeline stages, and then graph the results here. So as you can see, the tests that use Localstack run very consistently and predictably. Only about 40 seconds or so for the ones that are using the Terraform Test command. The Teratest one takes a little bit longer. I think I could improve that some by doing some module caching. OK, thanks. But the AWS ones, kind of all over the map. Definitely getting some that take quite a while. So hopefully that illustrates the differences. And with that brings me to the end. There's a few ways you can get in touch with me if you want. And thank you very much.